Hi, this is Mr. Krenz, and in this video I'm going to go through evaluating functions. Now what functions are they're a way of matching inputs with outputs. So we take a set from one thing and we connect it to another. And then there are lots of different ways of doing this, and in this video we're going to go through three specific to algebra. So the first way we connect inputs to outputs would be with equations. All right. So an equation might be given something like f of x is equal to x squared plus 1. So the word about what this left part says, what I say is f of x. And what it doesn't mean is it does not mean f times x. Even though there's parentheses, when we see this kind of notation, we think about it differently. What this tells us is that we have a rule f. So I'll write that down here. It means we have a rule that is named f. And what it does is it takes every x value, that's the input, and then it sends it to an output value that is x squared plus 1. Whatever that value is called the output. Okay. So let's do a few examples here and use this notation. So if I want to find something like f of 0, okay, I write it like this. Okay, for this means that the input is 0, and that means that the output then is I'm going to use this rule. I take x, and then what I do to get the output is I square that x, then I add 1. So I get 0 squared plus 1. 0 squared is just 0, so 0 squared plus 1 is equal to 1. Therefore, what that means is that f of 0 is equal to 1. And we can just write it like this. So it's important to note here that f of 0, when I write this thing right here, okay, that is not f times 0. To reiterate that, what it means is the value that f assigns to the input of 0. And in this case, that value is 1. Just a couple other examples. If we did f of negative 3, okay, that would mean take negative 3, use the rule, so the input's negative 3. What we're going to do is take that negative 3, we're going to square it, and then we're going to add 1. Okay. I put the parentheses around negative 3 to make sure that we do negative 3 times negative 3, which is 9. And then 9 plus 1 is equal to 10. So f of negative 3 is equal to a positive 10. Right? If I wanted to do f of 5, right, that means 5 is the input. So I use my rule right over here. I say I take that 5, square it, and add 1. 5 squared is 5 times 5, which is 25, and add that 1 to get a value of 26. Okay, so method 1 of evaluating functions is by using an equation, and the equation tells you the rule. Okay. Now the second method we have of defining functions and evaluating functions is to use graphs. So in this one we have a linear graph, it's just a straight line. We're calling this function y equals g of x, and we can do essentially the same thing. I could ask myself questions like, what is maybe g of 4? Okay. Now in this case, 4 is the input, and for these we're going to call the x's the inputs, and we're going to call y's the outputs. But it's actually just like the previous example. So I go and I find 4 as the input right here, and I look at that point, and actually its y value is 0. So g of 4 would be equal to 0. If I want to find a different example, I might be looking at what is g of negative 2. So what I do is that is my x value. So I go back and I see that negative 2 is right there for the x values, because I go from here back 2. Right, and then I go down to see where it intersects my function. That's right there. And that's y value is right here. And that is -3. So that means g of -2 is equal to -3. Alright. The last example here, I might consider something, say, like g of -4. Alright, so for that, I go find -4 on the x-axis, since -4 is my output. And that's right here. I drop it down to see where it intersects the graph. And now I say, okay, there's the x value. What's the y value of this point? The y value is how far is it down? And that is right here. So g of -4 is actually equal to -4. That's a special case where it matches the input to actually the same value for the output. So method 2 we have of evaluating functions, of actually defining functions, is we can have a graph. We find the x value as the input, and then the y value of whatever point that is going to be the output. Our final method of defining functions is probably the easiest one, and that's we can use tables to define functions. So in this example, I have a function h, and the way I assign the inputs to the outputs is actually I just look at the table. Right. So for this one, if I have the value, I don't know, what is h of 4? Oops, sorry, not 4. What is h of 3 we'll go with instead? Okay, that means that 3 is my input. H right here is the rule, and the rule is use this table. So I find up here, remember these guys, the x's are the inputs, and then h of x is the output. So when I look for h of 3, I'm looking right here, and the output is 8. Alright, so very simple in this case. Alright, if I want to look at h of 0, h of 0, find 0 there, and then its partner is right there. It connects the input of 0 to the output of 1. So h of 0 is equal to 1. The value of this whole thing is 1. Last example, I could do h of -1. Looking on the table, I see that -1 is connected to an output value of 0.5. Alright. So just to summarize, evaluating functions, what we're doing is we're looking at the way the function is defined and finding out how do we connect an input to an output. All right? If you're using an equation, that equation tells you the rule, which is like right down here. It says take the x's, or whatever variable you use, and then do this to them to get the output. In this case, it was squaring that value and then adding 1. So we have some examples here. If the function is defined by a graph, you go and find the x value, you go and find what y value goes with it on the graph, and then that's the output. If you have a table, the table just gives you directly the inputs and the outputs. So you just find the input and then match it with the output. Now just one final note of warning, just to reiterate this, f of x does not mean f times x, and I don't know if I can stress that strongly enough. It does not mean f times x, and please, 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 please never do that. All right. On the contrary, f of 3 is the value that the function f assigns to the value of 3, and that is right there. That is an input. Okay, so since in this example last here, we don't know what the function f is, but we do know that f of 3 is going to be equal to some number. All right, it is equal to a value, and with that value is whatever number f assigns to an input of 3. So it does not mean f of x.